Ginside.com. Ginside.com.
Mergesort, vastly faster than bubble or selection sort. It's a recursive algorithm that employs a little divide and conquer to solve the problem. It repeatedly chops the data in half until you reach one item, then merges the pieces back into larger sorted segments until the entire array is sorted. We're going to do this algorithm a little different. We're going to show you how it works. We're going to explain the algorithm first before we trace the code. We want you to understand how Mergesort works before we look at the code to implement Mergesort. Let's start with this array of 8 items, and the way we're going to solve this problem is to divide the array of 8 items into 2 groups of 4. So I've shown it as 2 separate pieces, and it does require 2 separate arrays to do a Mergesort. I'm going to show it split in 2, but we're not going to physically split the second array in 2. We're going to logically split the second array in 2. This showing it as 2 pieces is for visual effect only. It is not actually broken into 2 separate pieces. How do we solve the 4 pieces on the right? We divide the array of 4 items into 2 groups of 2 items. How are we going to solve the group of 2 items? We're going to divide the array of 2 items into 2 groups of 1 item. When we get into groups of 1 items, there's no way to split one item up. So now's the time to merge. We'll do the conquer phase of our divide and conquer algorithm. We'll merge the 2 pieces, 50 and 20. Since 20 is less than 50, we'll merge the 21st back into a larger array of 2 items. Right now we're working on 2 arrays of 1 item each. We need to merge them back into 1 array of 2 items. So the 20 merges first, and then the 50 merges. The 50 is the only thing that remains, so merge it back into the larger array. Do you see it? Do you see how we have 2 arrays of 1 item each that we merged into a sorted array of 2 items? That's the conquer in the divide and conquer. Through the power of recursion, we're going to flip over to the right side, split my array of 2 items. Here's an array of 2 items. We're going to split that into 2 arrays of 1 item each. Once we're into 2 arrays of 1 item each, there's no way to split it anymore. It's time to conquer. We'll merge the 30 and 80. Since 30 is less than 80, we'll merge the 30 first. Now let's conquer the right side. The 80 is left. We'll merge the 80 back into the bigger array. Once again, we took 2 arrays of 1 item each and logically merged them back into 1 array of 2 items each. See how both sides of these 2 arrays are now sorted? When we have it, it's time to conquer again. We'll take this logical 20 and 50 and merge it with this logical 30 and 80. And since 20 is less than 30, we'll merge the 20 first. Right now we're at the phase of we have 2 sorted arrays of 2 items each. We need to merge them back into a single array of 4 items. The 20 is the smallest from both sides, so we'll merge the 20 first. After the 20, we merge the 30. 30 in the remaining items is the smallest, so it merges next. Conquer. Merge 50 and 80. Since 50 is less than 80, merge the 50 first. What we're looking at is both arrays. What is left in both arrays? 50 is the smallest item that hasn't been merged, so 50 merges next. Finally, the conquer of 80. 80 is the only thing that remains. Merge the 80 into the larger array. Note the left array is now sorted. We have broken this data down, down, down to small pieces. Now we've merged them back into bigger pieces. This whole piece now is merged. It's conquered. It's done. When the left side is sorted, we now switch our attention to the right side. Now, how do we solve the right side? Why, breaking it up, of course. Divide the array of 4 items into 2 groups of 2 items. How do we solve a group of 2 items? We break it up into groups of 1 item each. We divide the array of 2 items into 2 groups of 1 items. Now, there's no way to split up one item, so it's time to conquer. Merge the 10 and 70. Since 10 is less than 70, merge the 10 first into the larger array of 2 items. 70 is the only thing that remains, so we'll conquer it by merging it back into the larger array. See how we took this 2 pieces and merged it back into sorted 1 piece. Flipping over to the right side, we'll divide that array of 2 items, 60 and 40, into 2 groups of 1 item. When we got 2 groups of 1 item, there's no way to divide it any farther, so we'll start our merge. Look who merges first. We conquer by merging 40 and 60. Since 40 is less than 60, the 40 merges first. The 40 merges first into the larger array. All we have left is 60, so we conquer the 60 by merging it into the larger array above it. All this is happening because of the stack. We're dividing recursively onto the stack, and when we're done dividing, we merge back in, and we use the parameters stored on the stack to tell us which pieces to merge. Now what we have at this point is 2 groups of 2 items each. If you look closely, I have 2 separate arrays, 10 and 70, 40 and 60. I need to merge these 2 groups of 2 into the larger group of 4. This is the conquer phase of our divide and conquer array. We're going to merge 10 and 70 and 40 and 60, and since 10 is less than 40, we'll merge the 10 first in the larger array, and there's the 10 merging into its proper position on the right side. What do we have left? We have 70 and 40 and 60. In the conquer phase, when we merge these two, since 40 is less than 70, 40 is the smallest number that remains on the 2 sides, we'll merge 40 next into the larger array. What do we have left? We have left 60 and 70. With 60 and 70 left, during our conquer phase, since 60 is less than 70, the 60 merges next. All that's left during our conquer is the 70. The 70 merges into the larger array. Note the right array is now sorted. If I have a sorted left array and I have a sorted right array, it's time to merge these 2 pieces into the larger array. You can see the red underline. The red underline goes all the way across. We physically didn't tear this array into 2 pieces. We logically separated it in 2 pieces, a left half and a right half. And when they have a sorted left and right half, what do I need to do? I need to merge them into the larger one. So we're going to merge the left side 4 numbers with the right side 4 numbers into the larger array. We're going to start by comparing the beginning of the 2 sides. We're going to compare the 20 and the 10. This time I'll go into a little more detail how the merge works. This is the conquer phase. Since 10 on the right is less than 20 on the left, we're going to merge the 10 into the larger array. Circle the 10 in red so you can see exactly what's already been merged. From this point, once 10 is moved up to the larger array, there's no need to look at 10 anymore. So I highlighted 10 with that red circle to show you that it's excluded. I've also moved this arrow over to show that this is the new front of the right side. 20 has not merged yet. 40 hasn't merged yet. These are the 2 next possible solutions for merging into the larger array. So the arrows underneath 20 and 40 are telling you these should be looked at next. The red circle around the 10 says we don't need to look at it anymore. It has already merged up into the larger array. Conquer. Once again, since 20 is less than 40, I'm going to merge the 20 into the larger array. The red circle indicates the 20 is done and we don't have to look at it again. The arrow under the 30 indicates that is now the front of the left side. I'm still merging the left array with the right array. The arrow under the 30 says I need to look at that next. The arrow under the 40 says that remains to be merged. Once again, in the conquer phase, since 30 is less than 40, we're going to merge 30 into the larger array. The 30 has moved up. The red circle around the 30 says we don't have to look at it anymore. This arrow here now says 50 is the front of the left side of the array. And this arrow over here says 40 is the front of the right side of the array. So the next comparison has to be between 50 and 40. And of course, in the conquer phase, since 40 is less than 50, we're going to merge the 40 next into the larger array. Notice how the arrow moved on this side. 60 is now the front of the right-hand side of the array. You'll notice that I have 4 values with red circles around them. Those 4 values and their red circles has indicated they have merged. Look at the 10, the 20, the 30, and the 40. Those have merged into the larger array. I'm only looking now at what's left. The 50 and the 80 is left on the left side. The 60 and the 70 is left on the right side. Those are the values that remain to be merged. The 50 over here says look at that next as a possible merger value. The arrow over here says look at that next as a possible merger value. And of course, in the conquer phase, since 50 is less than 60, we will merge the 50 in the larger array. Bang. 80 is now the front of the left side. 60 is now the front of the right side. Again, the red circles indicate this one's done. We can move to the next value on that side of the merge. Again, we're in the conquer phase. Since 60 is less than 80, we're going to merge the 60 next into the larger array. The arrow moving over here says 70 is now the front. All we have left to merge here is 80 on the left and 70 on the right. And guess who's going to merge next? The 70, of course. During the conquer phase, 70 is less than 80. So we're going to merge 70 in the larger array. Notice now the right side is 100% merged. The right side has red circles around it. There's nothing left to merge here. Fully conquered now. The 80, as being the only value left, merges into the larger array. Now the left side is fully merged. And the right side is fully merged. That's why I've declared this array to be conquered. Notice how the arrows here have now moved off the end of the left side and off the end of the right side. There's nothing left on either side, and you'll notice my data is sorted above. From 10, 20, 30, 40, 50, 60, 70, 80, I now have a sorted array. The merge phase is now done. Now what did we do there? We chopped the data in half over and over again until you got to one item on each side. Notice as you go down, chop the data in half, chop the data in half, chop the data in half. Once we've chopped it down to one items, we merge the smaller arrays into the sorted larger ones until done. We merge these two into this larger array. We merge these two sides into this larger array. And then finally we merged both of these halves into the larger array. That is Mergesort. Chop, 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 merge, merge, merge. The algorithm depends heavily on recursion and the stack to accomplish the sort. All of these chops are being pushed onto the stack. And then after we merge them, we pop them off the stack. And that keeps track of what needs to be chopped and what needs to be merged. To fully understand a merge sort, you're going to have to understand how recursion and the stack work together to pick up the algorithm. So there you have it. That is logically how the merge sort works. Now, let's look at the code that actually does the merging phase. Merge trace. Merge sort is vastly faster than bubble sort or selection sort. What we're going to look at here is we're going to trace the conquer, the merging of the divided data. The algorithm does require 2 arrays to merge sorted halves back into a sorted whole. That is one of the disadvantages of the merge sort algorithm. It does require an extra array for workspace. If you're going to merge an array of 1,000,000 numbers, you need 2 arrays of 1,000,000 numbers. The algorithm recursively merges smaller into larger pieces. We'll just trace the final merge in this example. At this point in the algorithm, the array has already been recursively chopped in half over and over again. The merge phase has already merged the smaller pieces back into the 2 sorted halves, and we're ready to merge them into the whole sorted array. So we're picking up the algorithm near the end. We have 2 sorted halves that we're going to merge into a whole, and that will be our final sorted array. Keep in mind, array 2 is a separate space. It is shown as 2 pieces for visual effect only, but it is a second copy of the array, not physically ripped apart, but logically we're looking at it as 2 halves. So here's the code. We're going to need to set up some variables to merge the left side of array 2 and the right side of array 2 into the larger array. Index is where the smaller value will be merged. Index is the location where we want to move the smallest number we can find into that location. The left variable is the starting point for the left side of array 2. Also notice we got a new way of displaying variables. I'm going to put this small red text next to the array index where left represents. Left set to 0 means 0 on the left side of array 2. Index, look at where index is. Index is set to 0. Index is a subscript into the original array, and when I set index to 0, that index above position 0 in the array is saying that's where we're located. The small red text for the left and index shows you where the arrays the values are pointing to. There are the index or subscript that we're going to access. I'm going to set right equal to 4. Right is the starting point for the right side of array 2. Again, this is a new way of displaying variables. I used to show you the variables over here on the side as their own separate space, and I would show you right over here with a 4 in it. Now I'm going to show you right exactly where it indicates. It's the right side of the array. End left is the ending point for the left side of array 2. The numbers between left and end left will merge into the array above in the proper order. This is the left side that has to merge into the bigger array. Between left and end left will define the numbers that have to merge up. End right is the ending point for the right side of array 2. The numbers between right and end right will merge into the array above in their proper order. Remember, merge sort takes 2 halves and merges them into the whole. Well, left and end left define the left half of array 2. And right and end right define the right half of array 2. And both of these will be merged into the larger array above. Index defines where we're going to merge to. Let's jump into the code. While left is less than or equal to end left, and right is less than or equal to end right. Well, this is 0 less than or equal to 3 and 4 less than or equal to 7. That is very much a true statement. While there is a number on the left and a number on the right to merge, execute the code in the loop. And that's what this arrow is saying. When this is true, I will go in and do this if else. If array 2 of the left subscript is less than the array 2 sub right, well, there's a 20 on the left and there's a 10 on the right. 20 less than 10 is a completely false statement. The smaller number is on the right side of the merge. We need to merge from the right. If I'm merging these two halves, 10 needs to merge first. And by going to the else portion of this, because the if was false, I'll go to the else. I will merge the number on the right. This is the conquer phase of our divide and conquer. Merge the 10 on the right into the larger array. Index is 0, right is 4. Notice how we moved from position 4 on the right side into index, and our 10 merged into our array. Also note the postfix plus plus. The postfix plus plus means after we do this assignment, we will do the plus ones. So the 10 moves first, and then we'll look at the plus pluses. The postfix plus plus notation says add 1 after the assignment is done. So index plus plus will move index to 1. Right plus plus will move right to 5. Notice the new way that I'm displaying the variables. Do you see how index moved up by 1? You see how right moved up by 1? I kind of like this new format. What it allows me to show you is where right went to. After I added 1 to right, it went from 4 to 5. After I added 1 to index, it went from 0 to 1. We can see both the old and new values as shown, but keep in mind right has now moved on, so we'll show the new values. Loop back and find the next value to merge. Look at where index and right moved. Index used to be 0, is now firmly 1. Right used to be 4, it is now firmly 5. We only now need to merge between right and end right. We need to merge the 40, 60, and 70 on the right side. Those are the only numbers left to merge from the right side. We'll come back up to our while loop. Left, which is still 0, is less than or equal to 3. Right, which is now 5, is still less than or equal to 7. So this whole statement is still true. We have plenty of numbers on the left. We have plenty of numbers on the right to merge. This is going to be a true statement, and we're going to go back to our if statement. While there is a number on the left, and there are 4 of them, and a number on the right, there are 3 left to merge, we're going to execute the code in the loop, and that's what this arrow is showing you. Array 2 subscript left is 20, less than array 2 subscript right, which is now 40. That is a true statement. Since the number on the left is less than the number on the right, I'm going to execute the code in the if portion. The smaller number is on the left. Let's merge the number on the left and skip the else this time. This is the conquer. When I merge 20 on the left into the larger array, index is 1, left is 0. Move the number on the left from index 0 to index 1. Once again, notice the postfix plus plus. I'm going to move the 20 before I ever add 1 to index or left. The postfix plus plus notation says add 1 after the assignment is done. Index moves from 1 to 2. The left goes from 0 to 1. Notice the new variable display. Index has moved to the next position. Left has moved to the next. Just temporarily, I'm showing you the old value of left. And just temporarily, I'm showing you the old value of index. Let's loop back up and find the next value to merge. Look at where index and left moved. I'm now firmly at 2 in index. That's where the next merged value should go. I'm now firmly a 1 on the left. That's what I should be looking at. I'll be looking at the number on the left and the number on the right and decide which one will merge next. We'll only merge what remains on the left side, 30, 50, and 80. Remember, the red circles means the 20 has already merged. The red circle means the 10 has already merged. I only have to merge what remains, 30, 50, and 80, and 40, 60, and 70. 1 less than 3 left is a 1, and 5 less than 7, well, that's a completely true statement. While there is a number on the left, and there are 3 of them, and a number on the right, and there are 3 of them, to merge, execute the code in the loop, follow the arrow, and execute the if-else statement. I have a 30 on the left side of array 2. Is that less than the 40 on the right side of array 2? Yeah, that 30 and that 40. 30 needs to merge next. The smaller number is on the left. Merge from the left, execute the if portion of the code, and skip the else. This is the conquer. Merge 30 on the left into the larger array. Index is 2, so that's where the 30 went. Left is 1, so that's where it came from. Note the postfix ++, we're not going to add 1 to index and left until after the 30 has moved. Postfix notation says add 1 after the assignment is done. Index goes from 2 to 3. That's why I'm showing you index is going from 2 to 3. Left goes from 1 to 2. Notice the new variable display. You can see where index and left have moved. Both the old and the new value of index are being showed. Both the old and the new value of left is being showed. The ++ is now complete. We can move on. We hit the end of the while loop and we back up and find the next value to merge. Look at where index and left have now moved. We will only merge what remains on the left side. 50 and 80 still need to merge. 40, 60, and 70 on the right still need to merge. You've got to kind of block out the numbers that are in red, block them out. They have already moved up. We don't merge them. 2 less than 3, left is a 2. That's less than or equal to 3. We still have numbers on the left. 5 less than 7, well, that's true too. We still have numbers on the right. While there's numbers on the left and the right, this statement's going to be true, and we're going to go inside the while loop and execute the if-else. The 50 on the left, array 2 sub left, is not less than the 40 on the right, array 2 sub right. So this is a false statement. As a false if statement, we will follow this line and execute the else code. The smaller number is on the right, merge from the right, skip 2 and execute the else statement. This is the conquer. Merge the 40 on the right into the larger array. Index is 3. That's where I want to go to. Right is 5. That's where I'm coming from. So I'm coming from the right and merging into index. Note the postfix notation. We're going to add 1 after the fact. Add 1 after the assignment is done. Index goes from 3 to 4. This will be the new merge position. Right goes from 5 to 6. We're going to exclude the 40 now. That's why there's a red circle around the 40. This is the new variable display. See how index has moved? See how right has moved? I show both the old and new values. We'll hit the end of the loop and loop back up and find the next value to merge. Look at where index and right have moved. Index is here saying I want the next merge value to go to this position. Right has moved here, so this is new the front side. This is the new front side of the right side of the array. We'll only merge 60 and 70 on the right side. 2 is less than or equal to 3. While there's a number on the left and there's 2 remain, and a number on the right, there's still 2 that remain to merge, we're going to execute the code in the loop. As long as numbers remain on the left side and numbers remain on the right side, this statement will be true. When this statement is true, we go inside the loop and execute the if-else. The 50 on the left is less than the 60 on the right. This is a true statement. The smaller number is on the left. Merge from the left. Execute the if and skip the else. This is the conquer phase. Merge 50 from the left into the larger array. There's the 50 on the left moving up into the larger array. Index is 4, so that's where the 50 goes to. Left is 2, so that's where the 50 comes from. Index goes from 4 to 5. Boom. This is our new merge spot. Left goes from 2 to 3, and we circled the 50 to say it's merged. We don't have to look at it again. Both the old and new values of left are shown here to show you where left has moved to. Hit the end of the loop, go back up, and find the next value to merge. Look at where index has moved. This is our new target position. Look at where left has moved. We still have an 80 on the left side that we need to merge with the right side, which contains 60 and 70. 3 less than or equal to 3 is still a true statement. 6 less than or equal to 7 is still a true statement. If both sides of the AND are true, the whole thing is true. While there is a number on the left and 1 remains, and a number on the right, 2 remain to merge. Execute the code in the loop. The 80 on the left is not less than the 60 on the right. This is a false statement. The smaller number is clearly on the right. Let's merge from the right. Let's skip 2 and execute the else portion of this if else. Every time the bigger number is on the right, we'll go down and do this else code. This is the conquer. Move the 60 from the right up into the larger array. Index is 5, so that's the destination of this assignment. Right is 6, so that is the source of this assignment. The 60 moves up into the larger array. Postfix notation says add 1 after the assignment is done. Index will go from 5 to 6, and I show you both. Right just moved from 6 to 7. We'll hit the end of the loop, go back up and find the next value to merge. We'll look at where index and right have moved. We'll only merge what remains on the left, which is 80, and what remains on the right, which is 70. This one's close, but it's still true. 3 less than or equal to 3 and 7 less than or equal to 7 is definitely a true statement. While there is a number on the left and 1 remains, and a number on the right, 1 remains to merge. Execute the code in the loop. The 80 on the left less than the 70 on the right is clearly a false statement. The smaller number is on the right. Let's merge from the right and skip 2 and execute the else. This is the conquer. The 70 on the right moves into the larger array. Index is 6, so that's where the 70 goes. Right is 7, so that's where the 70 comes from. Postfix notation says add 1 after the assignment is done. Index is going from 6 to 7. Right just moved from 7 to 8. See how index and right move? Right just moved off the end of the array too. This is different. Right just moved off the end of the array. I have a feeling something's going to change. Loop back up and find the next value to merge. Look at where index and right moved. We'll try to merge what remains on the left, 80, but there's nothing on the right. There's no numbers left on the right to merge. Look how everything on the right has a circle. Look how right has moved off the edge of the array. Something has changed. 3 less than or equal to 3 is still a true statement, but 8 less than or equal to 7 is a false statement. Right has moved off the edge. This while statement has gone false. While there's a number on the left and 1 remains, but no number on the right, there's 0 numbers left on the right to merge, we need to exit the loop. Look at this line. When the while statement goes to false, we will leave this loop. Now we're not quite done with the code. I'm going to show you some more here. I've added a couple of loops over here because this is not enough code to do the merge. We need to do a little cleanup here. Notice that left less than or equal to 3 is still a true statement. This is cleanup code. While there is a number that remains on the left, and there's one of them, we still need to merge what's left on the left side. As a true statement, we'll go in and we'll say array of index plus plus equals array 2 of left plus plus. The 80 remains on the left. Merge the 80 into the larger array, and there's the 80 moving up and merging. Now the left side is 100% merged. When we do the plus plus, notice how index goes off the end of the array. When we do the plus plus on left, notice how left goes off the edge of the left side of the array. We're making sure all the numbers on the left merge into the larger array, and there's nothing that remains on the left to merge. 4 less than 3 is a false statement. This again is the cleanup code. While there's a number on the left and 0 remain, we will exit the loop. We get down to the second loop, and 8 less than or equal to 7 is still a false statement. Once again, this is a cleanup code. While there is a number on the right and 0 remain, we will exit the loop and finally finish our algorithm. Both of these loops, the first loop says if there's any numbers on the left, merge them into the larger array. The second loop says if there's any data left on the right, merge it up into the larger array. Only one of these loops will execute, not both. The trace of the code is done. The last 2 while loops merge any remaining values on the left or right. Only one executes. You can't have data remaining on both sides. Well, there's our trace of the merge phase of the merge sort algorithm.